Recording. Hello, it's Brendan Wissinger today, and we're going to do solving the climate crisis in the electricity sector. So, ready for that? So, let's talk about of the global greenhouse gas emissions, electricity is the largest sector. It is 25% of global emissions. In the U.S., it is 27, second to transportation. So it's a very critical sector. So apparently I misordered this. Because it is the keystone for decarbonizing other sectors. We can decarbonize transportation, and we can decarbonize heating and housing and heating and that sort of thing. So back to where we were. So what types of energy of what we can get to, what we need to get to, we need to get to 100% clean energy. So that means maybe nuclear, rooftop solar, utility solar, concentrated solar power, onshore wind, offshore wind, hydroelectric through dams, hydroelectric through smaller things, tidal, and geothermal. And there are a few experimental renewable energy things out there. So, utility scale solar is like rooftop solar, except it's photovoltaic solar that's put out in fields or whatever, put out in solar farms. Concentrated solar power is what this thing is in the picture here, which is provides energy in the night and day. It can provide energy in the night and day, and how it works is a bunch of mirrors reflect reflect light energy onto a focal point, which contains some salt, and heats up the salt, and that heats water to create steam, which turns a turbine, which creates electricity, which turns a generator, which creates electricity. And then there's another type is onshore wind, which is less expensive than offshore, and wind turbines cause very low amount of bird deaths. The biggest thing that causes bird deaths are cats and windows. So skyscrapers actually cause for more bird deaths than wind turbines. Wind energy is greater onshore at night, and it's greater at night than during the day. Also, onshore wind creates, well, we're going to get to that in a minute. Offshore wind creates more energy than onshore wind because winds are more powerful over the ocean. But it's more expensive. And yeah. And there's a hydroelectric power dam, which you pretty much everyone knows what that is. The water goes through it and turns a turbine. Hydroelectric, small version, which is small turbines within a stream or whatever to create electricity that way. Tidal, which uses tidal turbines, which are like wind turbines under the sea, or they might be different in some forms that uses the tides to create electricity. And geothermal uses volcanic activity to heat water, to create steam, to turn a turbine, to turn a generator to create electricity. So, by at least 2040, all of our energy sources must be no fossil fuel, natural gas, and no coal. And I revised this to be 70% by 2030 and net zero by 2040. I didn't actually, it's in the PowerPoint. Currently I'll get to why in a minute. Our current energy sources in the U.S. is 33.2 is coal, 32.7 is natural gas, nuclear is 19.5, and renewable is 13.2%. Peaking power, which is the power that there's base load energy and there's peaking power. Peaking power is the energy that's variable. It depends that that you're going to need at peak hours, but you're not going to need most of the day. That can be given by biomass, energy storage systems, including lithium-ion batteries, zinc-air batteries, molten-state batteries, compressed air batteries, hydroelectric batteries, flywheel batteries, energy, their DC grid, nuclear. Several countries, for example, Costa Rica, Iceland, Uruguay, run on 100% renewable energy. 98% of Norway's electricity comes from renewable energy, and 90% of Sweden's electricity comes from carbon neutral sources. They got rid of their last coal-fired power plant this week or a week ago. When blackouts and brownouts are graphed to the amount of renewables, there's no correlation. There's no correlation that higher renewables mean more blackouts and brownouts. Actually, there's a weak correlation to the opposite. The more renewables, the less blackouts and brownouts. But I think that's more because if you're trying to put more renewables into your grid, you're probably funding your grid. You're probably putting more, or if you're putting more money into renewables, you're probably putting more money into your grid too. Some people say that there isn't enough surface area on Earth for renewable energy to provide for our needs, which is a laughable argument. Solar power, an area less than the surface area of Spain, when you look at the Sahara, that's a huge area. Most of it you could do solar panels with. That and also remembering this, all the solar power won't be in one place. So just that could provide enough for the world. That's not including any other energy sources. Offshore wind, 5.85 million square kilometers, which in terms of the ocean isn't that big. Onshore wind, which is half the area of Alaska, so that's a ridiculous argument. Cost of renewable energy cost of energy sources. So actually, the two cheapest here are thin film utility scale solar and the other wind. Or the three cheapest here are, they're listed here in order from what their cost is. The first one is the solar type of solar. The second one is the type of solar. The third is wind, a type of wind. And if you do their whole ranges, it would start off with wind, and then it would be thin film utility scale solar, and then crystalline utility solar, and then hydropower. So renewable energy is lower in price than, at least wind is, than natural gas. So and both solar and wind are less costly than coal. And coal, though some people, if you look at your bill for putting solar panels on your roof, that's going to look a lot different because, as you see, it's the last one. It's the most expensive, which I don't know why, but they charge people for that, but that shouldn't be. Anyways, so we're going to go through 9 policies, including 4 regulatory policies and 5 funding policies to decarbonize electricity sector. No more fossil fuel power plants. Okay, the lifespan of a coal-fired power plant is 40 years. The lifespan of a natural gas power plant is 30 years. Countries like South Africa, Japan, and Turkey are currently building coal-fired power plants. This has got to stop. No more natural gas, no more coal-fired power plants. It needs to completely stop. And we still are building in the U.S. more natural gas power plants. That's not good. So, and I'm going to explain to here what the target should be. So the IPCC says for 50% chance, half and half, of staying below dangerous climate change, or 1.5 degrees, we need a 50% reduction in emissions by 2030 and a net zero by 2050. And this is not taking into account how big the positive feedback loops are, the aspect of global equity, which means that some countries are going to have to take longer to mitigate their emissions, and assumes that my generation will be able to pull millions of tons of CO2 out of the atmosphere with technologies that are still in their infancy. That's not a very good bet. A good target would be 35% reduction by 2025, 70% reduction by 2030, and net zero by 2050. So, power plant standards. So, one of these type of things is, or number two, power plant standards. For one of these type of things is the Clean Power Plan. It was Obama's plan to reduce emissions by putting regulations on power plants to have them reduce emissions, and it would start in 2022 and reach a 30% reduction in emission by 2030. States got the choice to set their own standards. Would have gotten the choice to set their own standards, and it would have reduced emissions equal to taking 150 million cars off the road, reduced heart attacks, asthma attacks, premature deaths, and Americans received $7 more in health benefits. But Trump ended the program, so he, rescinded it. So number three, renewable energy portfolio standard. 29 states have them, as you can see in the map here. So renewable energy portfolio standards require a certain amount of the energy mix to include so much for renewables by a certain date. They can be enforced by utility. You may first upon the utility. For a certain utility, they have to have a certain percentage. Only a couple states are 1.5 degrees compliant with this, unfortunately. Those are Washington, Maine, Vermont, and some others too. California and New York are somewhat compliant. So number four, phasing out fossil fuel power plants. Removing fossil fuel power plants from the energy mix. So countries that are currently doing a phase out, the UK, France, California, Canada, Washington, Germany, Denmark, most of Europe, New York, Sweden, Maine, many others. They need to have, we need to ramp this up though, because we're not seeing enough focus on phasing out fossil fuel power plants as there needs to be. So, several countries have phased out all of their coal-fired power plants entirely. Some even all fossil fuels. Most countries and states in reality are not 1.5 degrees compliant. Like New York, I don't think it's 1.5 degrees compliant. I looked today, and it is, but barely. In reality, it isn't because of how conservative the IPCC's targets are, and they're 50%. It's a 50% chance. Number five, renewable energy, grid storage loans, and grants. So this is something the U.S. Department of Energy does, but I'm saying on this scale we might want to do another identity. And National Climate Bank. There's state climate banks in New York, Vermont, Washington, and other states. It's estimated between 1.5 and 2.5 trillion in funding will be needed to get enough renewable energy out there. But of course, the cost of inaction of the entire climate crisis, or the cost of inaction, is much bigger than mitigating the cost of mitigating, or the entire cost of mitigating the climate crisis, not just this. So we need to be able to do that quickly and scale them out. And that would do them in loans and grants, low-cost loans, grants, and other things. That's a good thing with Climate Bank before. Renewable energy tax credits. Currently, renewable energy tax credits are slated to end by 2023. This needs to stop. I don't know why Congress wants to put a sunset date on every single thing, but they love to. This needs to be extended and expanded until we reach 100% clean energy, which should be around 2050. This is when they can stop around there. They should keep going for a while. Subsidies for green energy allow green energy industries to expand and enable a smoother running of building green energy infrastructure needed to solve this crisis. We should put subsidies on green energy to allow. We should put subsidies for green energy to make this easier to do, to make it easier to have the supply chains of the correct scale and have enough out there, big enough manufacturing, big enough industry to be able to produce enough renewable green energy that we can actually solve this. That's what we need. Well, we need to subsidize green energy. Research storage. We need to put research into storage. So, because currently, though storage, we can do storage, it's highly costly. It's very costly, and we need to be able to we need to be able to store more energy for longer periods. So we need to invest in. Oh, this is number 8. We need to invest in scientific research into energy storage. So the last thing, a DC national grid, or a supergrid. China's already doing this, and this is basically because different areas of the country, like the cities in the east, are not the same place where most of the wind and solar power is. You build a giant grid over the entire country that is able to send electricity throughout the entire U.S. So you can have the plain states can send electricity to New York, whatever, and it's a DC current, so the energy doesn't dissipate, and it would allow us to also allow us to deal with peaking power more effectively. It would because different countries have their peak hours at different times. And the U.S. has different times at different places. That would allow that, and this would make the grid more resilient too. China's currently building one, and that's everything. So that's nine policies, and those were no new fossil fuel power plants. No new fossil fuel power plants. Power plant standards. Renewable energy portfolio standards. Phasing out fossil fuel power plants. Renewable energy and grid storage loans and grants. Renewable energy tax credits. This is going to become difficult. Subsidies for green energy. Research and energy storage, and build a DC national supergrid. So those are your 9 things. Thank you for listening to me. See you next time.